Welcome back to Summarize Science, where we break down the latest breakthroughs in research. Today, we're looking at a huge step forward in creating realistic 3D worlds from nothing but a set of photos. For a while now, AI methods like NeRFs and Gaussian splatting have been able to create stunningly realistic scenes. But there's a big catch. These methods build scenes using primitives, like fuzzy clouds of color, that aren't compatible with how video games or VR headsets actually work. Game engines are built on a foundation of solid, sharp shapes called triangles or polygons. Converting the AI's fuzzy clouds into solid triangles has been a major headache, often resulting in a loss of quality and extra work. This new paper, called Triangle Splatting Plus, completely changes the game. Instead of using a format that needs conversion, this method builds the 3D scene using triangles from the very start. The process begins with a sparse point cloud from the photos, which is then connected to form an initial mesh of triangles. The AI then meticulously adjusts the position, color, and opacity of every single vertex or corner of those triangles. It continues this process until its own rendered views of the 3D model perfectly match the original photographs. The result is a high-quality 3D representation that can be dropped directly into any standard graphics engine, running at incredibly high frame rates. As you can see here, they achieved around 400 frames per second on a consumer laptop. Because the final model is a standard mesh, it immediately supports things like physics simulations for collisions and creating walkable environments. It also makes editing the scene incredibly straightforward. Since every pixel in the final render corresponds to exactly one opaque triangle, you can easily select an object in a 2D image. And the system can instantly identify and remove all the 3D triangles that make up that object. When compared to other mesh-based techniques, Triangle Splatting Plus achieves state-of-the-art performance across the board. It consistently produces better-looking results that are closer to the ground truth. And it does this without needing complicated post-processing steps like other methods require to color the final mesh. The authors do note some limitations, such as difficulty reconstructing backgrounds with few photos or handling transparent objects like glass. But even with these challenges, the progress is undeniable. So, to recap the most important points. This method creates high-quality, game-ready 3D models directly from a collection of photos. The output is a standard triangle mesh, making it instantly compatible with existing tools for game development, VR, and simulation. It's also fast to train and extremely efficient to render. What does this mean for the future? Imagine being able to scan any object or environment with your phone and immediately use it as a high-quality asset in a virtual world. This technology bridges the gap between AI-based scene reconstruction and the practical needs of traditional computer graphics pipelines. It paves the way for a future where creating and interacting with digital twins of our world is seamless and accessible to everyone. That's all for this episode of Summarize Science.